Previously, we tested the claim that a linear correlation exists between paired variables x and y. Now we will find the equation of the straight line that best fits the sample data. The best fitting straight line is called the regression line, and its equation is called the regression equation. So the regression line and the regression equation. We can graph the regression equation on a scatter plot to determine how well it fits the data. We'll also see how we can use the regression equation to make predictions. Given a collection of paired sample data, the regression equation y hat equals b sub 0 plus b sub 1 times x algebraically describes the relationship between the two variables x and y. The regression equation expresses a relationship between the x, the independent variable, and y, the dependent variable. There are other names for x, the independent variable, and they are the predictor variable and the explanatory variable. It explains what's going on with y. This independent variable or predictor variable is affecting y, explaining the change in y. So we're used to seeing the equation for a line in slope-intercept form. Recall y equals mx plus b, where m represents the slope. So remember, we had m as the slope, and b was our y-intercept. Or in other words, the ordered pair, x is 0 and y is b. Okay, so now our new equation for the line looks like this. Y hat equals b sub 0 plus b sub 1 times x. So this is just the convention that sort of changes the order of these terms in the equation. So now we see this one is here and this one is here, but we essentially have the same equation. So from that we can see obviously that b sub 1 represents our slope and b sub 0 represents our y-intercept. It's just the convention to write it this way. Now, just to make it a little more interesting, on the TI 8384, the notation is y equals a plus bx. Or actually what they do is they give you a, well let me write it this way, b is your slope, and now a is the y-intercept using this technology. So the calculator will give you a b value and an a value, but we do need to understand where those go. B is representing our slope and a is representing our y-intercept. So now let's look at our notation for the equation of a regression line. Okay, so we will have a sample statistic and a population parameter. I'm going to abbreviate the population parameter. Okay, so we'll have first the y-intercept. Now the notation in our textbook has that as b sub 0. Remember we said that up here. B sub 0 is the y-intercept. And the parameter, recall that for the most part our parameters use Greek letters, and so we'll use the letter beta sub 0. Statistic, just the regular English letters. Parameter, we use the Greek letter. Okay, the next thing is the slope. We said in our textbook that's going to be b sub 1. The parameter then is beta sub 1. And then finally, what's this equation? Well, for the statistic, it's y hat equals b sub 0 plus b sub 1 times x. For the parameter, it's y without the hat. Remember, y hat is a predictor. Y is our population of beta sub 0 plus beta sub 1 times x. And the requirements for regression are the same as they were for correlation, so I won't go back over those, but it's just the same as we went over for correlation.